calculate how high the building would be above ground. In other words, determine the total height of the cliff plus the building. Okay, so we want, ultimately, we want all of this. Okay, this is like our ultimate goal, to find that height. Okay, what do they give us? That angle BAC is 148. BAC is 148. So this is 148 right here. That is 148. Question. If that's 148, what is this? What do we have here? You see that? You see that? That's 180, right? If you see that. So if this is 148, then this is 32, right? This one right here. If you didn't catch that, you have a triangle here. This is 58, right? And this is a 90 here at this corner. You can go ahead and put a 90 there. And so remember that. Where do I start? Well, I would argue that you know this side of this triangle right here, correct? You need a side length. So this is 30 meters right here. This stretch from here to here. So that's the triangle I'm going to start with. So I'm going to sketch it out here. So what do I know of that triangle? I know this is 30 meters. Okay, I know that this is 148. Do I know, I'm going to use a highlighter for this one. Do I know this angle right here? It's this wedge right there. Do I know that? This is 64. This is 58. I could just subtract these two angles and I'm left with that little wedge. Does that make sense? Okay, so 64 minus 58 is going to give you a small angle of 6 degrees. So the 6 goes in here, 6 degrees. Okay. So you've got, it's hard to see, okay, but the 6 is across. If you travel out from that angle, you hit that 30-meter side. Okay, so this is your pair. How is that going to help me? I will argue that I want to figure out a side that I share. I share this side. Right? This triangle shares this side with the right triangle here. I'm going to try to find this side ultimately and add up the height here of the cliff or the hill and the 30. If I combine those two, I get the total height. So that is my goal. So I'm going to call this Y. I have a pair here. To get side Y, I need this angle up here. So I'm just going to go 180 minus 148 minus 6. You get 26 degrees. Okay, so this is 26 up there. So sine of 6 over 30 and then sine of 26 over y. That's going to be my approach here. Okay, so let's go and try that. Sine of 6 degrees over 30 meters and sine of 26 over y. Let's solve that. Y is equal to 30 times sine of 26 over sine of 6. And y is going to give me 125.81. And I'm in meters. This is the orange side, right? That's what I started with. Okay. And now what? Now I'm going to transition over to this triangle here. So this one is 125.81. This is 90. This is what? What's this angle right here? Is it 64 or 58? This one. This is the side that represents this slant right here. So this is 58. Okay, this is 58. 58 degrees. I'm going to call this Z from here to here. I have my pair. I'm going to use the 58 to find Z, right? So sine of 90 over 125.81. Sine of 58 over Z. So Z is 125.81 times sine of 58 divided by sine of 90. Anybody remember what sine of 90 is? It's just 1, okay? So next time you go to the cafeteria, you know, can I have a sine of 90 Coke, please? And sine of 90 French fries on the side. You got to be smart, and you got to have a sense of humor, right? Anyways, Z is 106.69. We're in meters. Let's highlight. Who highlights these days, right? I do. That's the green part. So we now need to add up the green part, this part right here, which we call Z. We got to add that to 30. And then we get the true height of the building. So side X is going to be 106.69 plus 30. So that's 136.69 meters. That, ladies and gentlemen, that is the final answer. This is rare on an exam, but we don't know what they will throw at us. We cannot rule out anything, okay? So if you're comfortable with the ones we've been doing at the very beginning, where it's just like this is a triangle, solve for the angle, solve for the side, if you know how to do that, you're doing pretty good, okay?